everyone. On behalf of our team, I will present the analysis of ABC Bank's credit card approval machine learning project. We will demonstrate how this data-driven transformation upgrades traditional decision-making into an efficient, precise, and automated approval system. Our foundation system consists of 5 historical records with 20 features covering personal, financial, and contact information. The objective is clear, using binary classification model to predict approval status based on historical patterns. Let's address our first core prompt, the key processing steps. Through optimized edits, we found the data was noisy. Total income had 72 outliers and years employed have 94. To ensure robustness, we use visualization. Instead of to deleted valid data, we form extreme values back to specific percentiles like the top 1%, mitigating extreme bias without losing samples. Next is feature transformation. First, we use one-hit encoding to convert text variable like on housing types into binary vectors. For occupying types, we implicate real character grouping. We aggregating each profession like HR or IT staff to present overfitting on small database and improve generalization. We also apply 2 advanced techniques on PCA, principal component analysis, compressing 20 plus features to extract maximum variance and reduce noise. K-means clustering, creating custom personalized features, for example, like grouping yarn high earners helpfully classify capture nonlinear risk patterns and the simple models might miss. Now for the second core prompt, model suitability, we adopt a companion challenger strategy to balance precision and explainability. Our key metric is AUC, model's overall ability to discriminate between good and bad applicants. So why regression? It is our regulatory anchor. In banking, we need a white box model. Logistic regression maps features ways directly to approve us, providing clear data codes for denying letters and ensure compliance with fear leading laws. So what about the random forest? It is our perform challenger. It excel at handling non-linear relationship and is naturally robust against reminding artists. It's ultimately like the tact complex interaction between features, providing the higher predictive selling. Finally, we utilize the Optimal like Pi, Caret, and H2O list tools perform exhaustive searches and automotive on high parameter tuning. Ensure we don't overlook better system due to human bias. They ensure our project remains technically state of the art. In summary, we are optimize data quality through processing like visualization and clustering and address the balance of fairness and accuracy through combined modeling with logis logistic regression and enable methods. ABC Bank's feature is a swift from institution to evidence-based precision, enable real-time risk scoring. Now let's reflect on the insights from our machine learning project result. This part divides into how to our data preparation and future engineering shaped the model performance, the strengths and the limitation of our techniques, potential improvement, and the real-world implications. We'll break it down into four key areas. Data preparation and future engineering, like tuning a musical instrument before performance, the set the stage for a model to play its best. In our project, we start by cleaning noise data such as capping outliers in total income and years employed using utilization. This presented extreme value from encoding for housing types and real character grouping for uh, occupation. We transformed qualitative data into quantitative on signals that model can understand. These steps directly boost performance by reduce noise and highlight meaningful patterns. For instance, without this, model might overfit to outliers or miss risk factors, leading to lower accuracy. And also, good data pre ensure the model focus on real signals, not distractions, resulting in higher AUC score and better generalization to new applicants. Our techniques had clear strengths on visualization, present data integrated by capturing atlas instead of deleting them, so which is crucial for a small data set like our 5,000 records. And for feature engineering, such as one hot encoding made character character virus machine reliable, while real character category grouping prevented overfitting by combining each professions. Additionally, advanced methods like PCA and clustering unlocked on latent patterns. PCA complex features into principal components, reduce noise, and also improving efficiency. Clustering, creating cluster personnel features like identify young high earners on which captures non-linear relationship that simple feature might miss. However, they all have limitations for visualization can mask two high-risk outliers by creating um, article caps and our small data sets risk sampling bias. Also, techniques like clustering adds complexity, making models harder to interpret for regulatory compliance. Overall, this method balance robustness with explainability, but we must be mindful for their constraints. To improve further, we can focus on three areas: data, techniques, and model diversity. First, extended the data set beyond 5,000 records would reduce sampling bias and provide more representative patterns. Second, we can experiment with more advanced feature engineering, such as using domain knowledge to create customer customer risk score or incorporating time series trend for employment history. For example, instead of just Vanillization, we might use robust scoring method that can that sensitive to outliers. Third, enhancing model in diversity by testing ensembled method like gradient boosting or deep learning could capture even deeper patterns while using explainable AI tools to address the black box issues of complex models. Additionally, constant continuous monitoring and retraining with new data would keep model adaptive and on changing applicant behaviors. By iterating on list steps, we can push accuracy beyond our 92% and ensure fairness. The outcomes reliable patterns that are highly related for real-world banking. For instance, the Custer personnel feature showed that risk factors often combine in non-linear ways, like young applicant with high income being low risk, which traditional rules might miss. This implies that ML models can uncover, handle, streaming, enable more personalized credit scoring. In practice, this means ABC Bank can switch from institution-based approach to evidence-based decision, reduce human bias, and improving on efficiency. However, it also highlights on implications like need for transparency on regulated might require clear reason code for denials, which simple models like logistic regression provide. Overall, these project stress that banks should adopt a hybrid approach, a balancing accurate models with explainable ones to foster trust and compliance while leveling data for the real-time risk assignment.